In this video, we're going to be finding out when limits fail to exist. So let's go ahead and let's look at the objective. Determine if a limit exists. So you're going to have to work some problems out and determine if the limit exists. Number 2, determine the 3 reasons why a limit fails to exist. And number 3, define algebraically when a limit exists. So let's go ahead and look at the 3 reasons why a limit fails to exist. Number 1, this one, when we did one-sided limits, you found out that the limit doesn't exist when the left-hand limit is different from the right-hand limit. So the notation for this, we're going to say that the limit of f of x as x approaches c from the left is not the same as the limit of f of x as x approaches c from the right. So those 3, that's the first reason why the limit fails to exist. The next one is when the function is oscillating between 2 values. That's when the limit exists. And finally, the third time that a limit can fail to exist is when there's an asymptote. When there's an asymptote, automatically the limit fails to exist. And some of you say, wait a minute, sir, but I thought that when there's an asymptote, the answer could be infinity or negative infinity. That is correct. However, you need to understand that infinity and negative infinity are not y values, they're locations. So therefore, the limit does not exist is the true answer. So let's go ahead and visually look at each one of those. Find me the left, if you look at this one, and we're looking at 0, we're going to say right here at 0, the limit does not exist, right here. The left-hand limit is different from the right-hand limit. So at 0, they're not going to meet. Therefore, the limit does not exist. All right? Now, here's an interesting function. And you have a function here that is oscillating between -1 and 1. Okay? Now, if I was to substitute 0 into my function, I would have 1 divided by 0. That doesn't exist in mathematics, so we can only assume what's going to happen there. So my function is oscillating between 1 and -1. So somebody might say, well, sir, it's going to approach 1. But then somebody else might say, well, it's going to approach -1. So who's right and who's wrong? Because it's oscillating between those 2 values, we say that the limit does not exist. The third and final way that the limit does not exist is if there's an asymptote. So if you look at this function right here, there's an asymptote at 0. Okay, there's an asymptote right there. Even though it's defined, and there's my dot right there. As you can see, there's a dot right there. They defined it. This little piece defines my dot right there. Just because it's defined doesn't make it have a limit. So let me explain why. If I come from the right side, my graph is going to be approaching infinity. But as I come from my left side, my function is approaching negative infinity. So guess what? They're different values, therefore the limit does not exist. All right, so what are the 3 ways that the limit fails to exist? Number 1, the limit of f of x as x approaches c from the left is not the same as the limit of f of x as x approaches c from the right. Number 2, if it oscillates between 2 values, And finally, number 3, if there's an asymptote. And that's it.